What's up to you all, grade 12 matriculants, Mindsetters? It is a lovely Monday. It is a Triple M day, Mindsetters Math Monday. I hope you're up and ready to learn more with this, and I hope you had a great weekend. By the way, let me know, how was your day at school? How was your maths class? Did you enjoy it? What did you guys do? Share it with me on Facebook, and I'll share it with the rest of the world, which is the Mindsetters. Otherwise, in this lesson, we're joined by our awesome teacher, Mr. Sihle. Kunjani ba?
Grand, in fact, grand.
Mphilile now.
Late Valentine though, yeah.
Oh,
So I had it over the past weekend.
oh, by the way, that's why you're wearing a red shirt.
I think so.
Right, no, thanks to that special mindset. I'm just kidding. Let me just say this. What are we doing today?
We're doing maths. Okay. No, we're doing graphs of inverses and all the functions. Continuation of last week. Yeah.
All right, Mindsetters, to chat with us, go to facebook.com/LearnExtra, and to tweet us, go to @LearnExtra. Follow us, tweet us, and I'll read some of your tweets later on. And if you have some questions, also tweet them. I'll read them to our teacher, and we'll take them and answer you. Otherwise, download the notes all for free at learn.mindset.co.za. They're all for free. If you get to the notes, there is a test yourself questions whereby you answer those questions and then send them to us on the link that is provided on Facebook, and then you stand a chance of winning an awesome airtime voucher, proudly sponsored by Vodacom. So it is an awesome opportunity for you, Mindsetters, to call all your friends. And before I just announce our winner from last week's show on Thursday, we also have a challenge question. But before, tell us what we're going to be doing in terms of the description of the lesson.
Okay. Today's lesson, as you can see, we're working with graphs of functions and their inverses. So we'll try and tackle most of the questions, the graphs, but working on their inverses today. Yeah.
All right, awesome. And the winner, drum rolls, for last week's show is Nomcebo Noncedo. Noncedo, congratulations. Noncedo Swelana, congratulations to you. You've won yourself an airtime voucher. And I must say that Noncedo Swelana is winning for the second time. So it is possible, Mindsetters. Congratulations. Your second airtime voucher, proudly sponsored by Vodacom, is coming your way. We'll give you a call. Let's get to it, sir. The challenge question.
All right. Thank you very much, Abram. We've got our challenge question today. Please take it down. Yeah. Thank you. Some of you have got pens and papers. It's given that g of x equals to 3x. Find a simplified expression for g of x plus g to minus for the inverse plus 1 over g of x plus g of 1 over x. There's quite a lot of notation there, but we're going to look at it a bit later. Yeah, there's it. They've got it.
Thank you. Let's get to it.
Okay. Now, guys, our work for today, although I'm just going to do a quick revision, just a recap on last week's show. We looked at the function, right? And we defined it as a mathematical rule that maps an input value to a unique output value. And we looked at the domain and the range. And we said the domain, as we're looking at the x, so it's a set of all input values, and the range is a set of all output, which is your y in that case. Now, if we look at the graphs and their inverses, starting with a linear function, which is your straight line. Say, for instance, you're given y equals to 2x plus 2, and you need to work out the inverse of that function. Remember, when you're getting the inverse, you interchange the x and y. So now this was y equals to 2x plus 2. Now it's now x equals to 2y plus 2. Now, normally we leave it in the form of y equals to mx plus c. So in other words, we're making y the subject of the formula. So you get your x minus 2 equals to y, divide everything by 2. So you get x divided by 2 minus 1 is the inverse. Now remember, this is a straight line. For x-intercept, you make y naught. Y-intercept, make x naught, what we did last week. And you've got your function here, which is your original function, which is a 1-to-1 function, and your inverse interchanging x and y. Now remember when to tell when it is a function or not, and the restrictions that we did last week, how do you restrict it to be a function. Now we go to the hyperbolic function. Now guys, remember, if you work out the inverse of the hyperbola, you're given, say, for instance, this is y equals to, I've got y equals to 2 divided by x. Now, if you were to work out the inverse of this function, interchange the x and y, let's see what we get. You get your x equals to 2 divided by y, then xy, it's equals to 2. So therefore, the inverse, it's 2 divided by x. So the inverse of 2 divided by x is 2 divided by x, so it's the same function. But how about if we go and say the very same hyperbola, say for instance you're given y equals to 2 divided by, now it's x minus 1 plus 3. Now, the inverse for this function, remember we interchange x and y, so your inverse will be, okay, let me just get a different pen, y equals to 2 divided by x minus 3 plus 1. Okay, how did we get that? Now, if we look at this function, we said for x, you make it y because it's reflected, okay, although it's not part of your CAPS document, but it's a reflection on y equals to x. So what you do is you have y equals to 2 divided by x minus 1 plus 3, then interchange x and y, so we've got x equals to 2 divided by y minus 1 plus 3. Then you take the 3 across, so you've got your x minus 3 equals to 2 divided by y minus 1. Cross multiply, we want to make y the subject of the formula. So you get to y minus 1 bracket x minus 3 equals to 2. Then y minus 1 equals to 2 divided by x minus 3. Right? Making y the subject, so I'm going to add 1 on both sides. So you've got y is 2 divided by x minus 3 plus 1. So we've got what we predicted there. So y equals to 2 divided by x minus 3 plus 1. Now, just there, back at home, what do you think the inverse of this function will be? Please post it on Abram's page, which is your Facebook, and give me the answer. Now, guys, you've got a quadratic function. This is y equals to x squared. Now, how do you get the inverse of y equals to x squared? Right? So you interchange again. So you have your x is y squared, then y is plus or minus the square root of x. Now, you have to do some restrictions here. You've got y equals to plus or minus the square root of x. Now, say for instance, I put a minus 4 in the place of x. So you get y equals to plus or minus the square root of negative 4, which becomes a complex number. So you have to restrict this. Right? So you're going to say for your x should be greater or equals to 0. Because if you sub in a 0, you get y equals to plus or minus 0. And sub in 1, y equals to plus or minus 1. So you have restricted that your domain. So now that is why we get this function, this relation. You've got y equals to x squared, then you have your y equals to plus or minus the square root of x, which is this graph here, right? And then for your y, say for instance, you've got your y equals to minus x squared, and this is when you work out your inverse, here you get your x is negative y squared divided by a negative 1 throughout, so you get your minus x equals to y squared, therefore y equals to plus or minus the square root of negative x. Now remember what I said earlier, you restrict your domain for that. Now if you put positive numbers there, if you say for instance x is 100, you get the square root of a negative number, so that's why we have to restrict. So x should be less or equals to 0. Because if you get minus 1 times minus 1, you get a positive 1. So you can have, when x is minus 1, y will be plus or minus the square root of 1, which is 1. Now you've got your exponential function, and which is y equals to 2 to exponent x plus 1, and your asymptote, your y, may not be equals to 1, right? Then you've got your exponential function. Now, next, when you do your inverse, this is now when this was y equals to 1. That is your asymptote. So the next one for your inverse, then x equals to 1. So that is why we have that one. The graph is not going to touch at x equals to 1. Right? Abram, any questions so far?
No, I just been getting your answers in the question that you asked earlier on.
Okay, so quick.
Yeah.
Okay, thank you. All right, now, guys, back to business. We've got our first question, right? So it's given that px equals to minus 3x squared, all right? Find the equation of the inverse of p, inverse of this function, stating its domain and range. That's the first one. You can do it at the moment, right? Just going to go through this question. Okay, draw a sketch graph of p and the inverse of p on the same set of axes. So you're busy at home, you're looking at the equation of the inverse, and you're giving me the domain and range, okay? And then the next part, you draw that graph on the same set of axes, so you draw the inverse and also the function itself, all right? And now you have to tell me why this inverse of p is not a function. So you need to remember when you're stating how do you find if this is a function or not, all right? Now next, how must the domain of p be restricted such that the inverse of p is a function? Okay. Abram,
Yes.
do you have anything to talk to your
I think
friends?
that question is very interesting that the mindsetters need to get a chance of going over it, digest it, and then we'll come back to it after
Okay.
the break.
No problem.
Is that cool?
I think that's cool.
All right.
It's good. It's cool. Yeah.
It's cool to be at school with mindset. Otherwise, mindsetters, you've got a lot to deal with during this set break. The test yourself questions, they're there, and you'd stand a chance of winning an awesome airtime voucher. You also have the challenge questions that is there on Facebook. And lastly, you have this question to think about. We'll see you after this break. Welcome back, mindsetters. We love hearing from you, and thank you for the questions that you guys are sending. We'll deal with them later on. Keep them coming on facebook.com/LearnExtra and on Twitter @LearnExtra. But for now, let's continue.
Okay. Thank you, Abram. I'm sorry that's not Abram's page. It's Mindset.
No, it
Facebook.
is my page. You don't
Okay,
have to
that's
be
your
sorry.
page. Okay.
I am Mindset.
All right. Now, okay, I've given you these questions before the break. Find the equation of inverse of p, right? Stating its domain and range. Okay? I'm sure you've done it. So you're given y equals to minus 3x squared. Okay? And we said for your inverse, you interchange x and y. So where I see x, I put y. Where I see y, I put x. So this is x equals to minus 3y squared. And then next, I have to make y the subject of the formula. So now I have next, I will have to divide by minus 3, right? So I've got x divided by minus 3 equals to y squared. So therefore, y is plus or minus the square root of x divided by negative 3. Now watch, very important here. If you look at this, you've got y equals to plus or minus the square root of x divided by minus 3. Like we've been saying, I cannot have positive number here in the place of x because I'll be getting my square root. I'll get a negative, the square root under, okay, English, let's go back, the square root of a negative number. Okay, thank you. Now, so I do some restrictions here. So I'd have to say x should be less or equals to 0. Because if I put, say, for instance, a minus 12, I'll get the square root of negative 12 divided by 3, which is 4. So the square root of 4 is 2. So now, if we look at this graph, just for interest's sake, I've got naught and naught, right? Now, if I sub in maybe minus 3, so I'll get minus 3, and my y values, I'll have minus 1 and 1. And if I sub in minus 12, I'll get plus or minus 2. So it's something that to look like this. Okay. Now, I have to do my domain and range. So now I can have any x value, right, up to where x is not. Then next, I don't have anything. Like my restriction here, x should be less or equals to 0. So my domain in this case, domain is x such that x is an element of, and start from negative infinity, and then I stop and including a 0. Okay? Now with my range, y is an element of, so I can have any y value starting as from negative and up to your positive infinity. So y is an element of negative infinity to positive infinity. This is not a 8 that has fallen down. Okay, it's infinity. Okay. Oh, nice. It's saying draw a sketch graph of P and the inverse of P on the same set of x's. Okay? Now, we've got y equals to minus 3x squared. Right? This graph is roughly not and not. It's negative. I'm sure everyone, you all can do that. Right? So you've got y equals to minus 3x squared. Now, the inverse, because we restricted here, we said x should be less or equals to 0. We've already drawn the inverse for you, but I'll just quickly do it on the same set of x's. This is your inverse, different color. So this is your px, and then this is your p minus 1x. So this is the original function, and that bluish is of your inverse. Okay. Now, here's the next question. Why is the inverse of p not a function? Now, remember what we said last week. For graph to be a function, it has to go through a vertical line test, right? Now, if we look at this inverse, if I draw a vertical line and I move my ruler, right, I'm meeting the y values for 1x, 2 y values. Now, can you see that this one fails the vertical line test? So it is not a function. So p, the inverse of p, is not a function because it fails the vertical line test. Okay, so the reason why this is not a function, because it didn't pass the vertical line test. Now the next question says, how must the domain of P be restricted such that the inverse of P is a function? Okay? Now, this is, let me just draw it here. I've got y equals to negative 3x squared. We had the graph there. Okay. This is y equals to minus 3x squared. This is y, and that is x. Now, how do I restrict this one in such a way that the inverse of this graph will be a function. Now, if I look at this part, that part from the node going to the right of my my function from x and on, x positive, right? So I'll get a one-to-one function. So I'm saying if I can restrict my domain and say x is greater or equals to naught, then I will have my inverse being a function, which is going to be a one-to-one function in that case. And also, if I were to exclude this part and have my left from naught and going negative, so here I'll have x less or equals to 0. So how do I restrict the domain of this function? I would say if x is less or equals to 0, or when x is greater or equals to 0, I will have my inverse as a function, which in this case is going to be a one-to-one function. And remember, we said, how do you tell if it's a one-to-one or many-to-one? You use your horizontal line test. Now, guys, moving on to the next question, right? It's given that f of x equals to 8x plus 32 all divided by 20 and g of x equals to 5x divided by 2 minus 4. Calculate f of 1, g of 1. Now, in other words, if I have x as 1 and this function, what is my y value? If I have x equals to 2, in your g, what is your y? Okay. Now, we have f of 1 equals to 8 bracket. Now, I've taken out x. I'm putting 1. So in the place of x, I'm going to have 1 plus 32 all divided by 20, which gives us 32 plus 8. That's 40 divided by 2 by 20. That is, man, this is not 20. 40 divided by 20, that's 2. See, izinto zabelungu apha.
Technology.
Right, that's 2. Technology. I know we'll fix it. We'll fix it. We're getting there. We're getting there. All right, and then your g of 2 is 5 bracket 2 divided by 2 minus 4, which gives us a 1. So in simple terms, f of 1 plus g of 2, so f of 1 plus g of 2 equals to, we get a 2 plus a 1, and what is 2 plus 1? Thank you, you've passed your maths. 2 plus 1 is 3. Okay, so f of 1 plus g of 2 equals to 3. Now, again, English there. Verify that g is the inverse of f. Now, we need to prove that our inverse, that g is the inverse of f. So in other words, we should have f, which is 8x plus 32. So y equals to 8x plus 32 divided by 20. Now, in order for us to work out the inverse, we said we keep on saying interchange your x and y and simplify, make y the subject, okay? So I've got y equals to 8x plus 32 divided by 20. So now work it out quickly. So x is 8y plus 32 all divided by 20. Now remember, I want to make y the subject of the formula. I'm going to multiply through. You can say cross multiply because this is a denominator of 1. So if you cross multiply, you get your 20x equals to 8y plus 32, right? And there is a common factor here. You can divide by 4 throughout. So if you divide by 4, you get 5x equals to 2y plus 8. and I want to make y the subject of the formula. So I've got 5x minus 8 equals to 2y. Now I want to get y on its own, so I'm going to divide through by 2. So if I divide by 2, I get 5 divided by 2x, 5x divided by 2, minus 8 divided by 2, it's 4, equals to y. Now we go up to that function now. Very nice. So g of x equals to 5x divided by 2 minus 4 is actually the inverse of your f of x, because your left hand side is the same as your right hand side, which is in this case is a g of x. Now I hope that helps. We move on to the next question. Question 3. Now you're given, okay guys at home, this is a straight line up to your origin, and this looks like an exponential one. So but then we've got 6 and 4, and it stops there. We don't have this. Okay, so it stops and then it starts over. So you've got give the domain and the range of the above function. So guys, can you see it's starting at minus 2. So when x is minus 2, and it goes up through the origin and up to when x is 6. So what you're going to say is the domain of this one is x is an element of, now I'm including the negative 2, so it's from minus 2, okay, sorry, and stop at 6. So I'm using square brackets. It's starting, so including the negative 2, and I'm also including the 6. Now the range is y is an element of, we start at negative 6 including, and we stop at 4. Okay, now that's our domain and range. Now this saying, next question, sketch the graph of the inverse of this function on the same set of x's. Now remember guys, when we were working with this, we said we interchange x and y. So here it is clear, and this looks like it's drawn to scale. So you've got 1, 2, 3, 4, 5, 6, and 4. So it's 6, 4. So the inverse, your inverse will be, now this coordinate here, interchange x and y. So you'll get your 4, 6. Okay? So I've got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So there's a point there, which is 4, 6. Okay, and I've got another point. Okay, that is going to be your 4, 6, and this is not a knot, and it's reflected about the y equals to x. So I'll have a graph that looks like that. That part, I'm going to have that, and with this one I have minus 2 minus 6, so it means I'm going to have minus 6, 1, 2, 3, 4, 5, 6, so minus 6 and minus 2, and then I join those. It's a straight line, right? Though it does not look that straight, but this is minus 6 minus 2. So this is your inverse. It looks very nice. Okay, so you've got minus 6 minus 2, those are your graphs. Now explain why this inverse is a function. Guys, when we do a vertical line test here, can you see that you've got 1x, 1y, 1x, 1y? So this function passes your vertical line test. So the inverse is a function because it passes the vertical line test. Okay. Anything from you, Abram?
I just have the mindsetters answering the challenge question, which is good. Keep those answers coming, mindsetters, because we'll answer you later on. And some questions from the mindsetters, we'll also take them later on.
Okay. All right, guys, our next question will be, Okay, you are given a graph, more or less the same as the one before. So they're asking you if this is f a one-to-one function. You need to explain and sketch the graph of the inverse of f, and maintaining the range, give a restriction on the domain of f that would ensure that this is a function, right? Abram, I think we should go for a break, get some water.
I think so. On that note, mindsetters, know that all your notes are on learn.mindset.co.za. So mindsetters like Lucinda Withle, who's been asking me of the notes, yes, they are found on that link. Otherwise, we'll see you after this break. Welcome back, awesome grade 12 mindsetters. Now, about the competition, I did mention earlier on that our winner is Noncedo Swelane, who has won herself a 110 voucher for the second time. So she's having 220 bucks to call people. So Noncedo, if you're watching, check out your emails. Mindset has contacted you, and maybe you're going to call us, eh? Maybe. But otherwise, Mindset, it's a good thing. Do send us those set yourself answers on the link that is provided on Facebook, and you might be our lucky winner, which will be announced tomorrow. So stay tuned.
Thank you, Abram. We're waiting to receive some calls from our learners.
Because they've got airtime.
They've got airtime. We just send a please call me. Right now, I've given you question 4, guys. And the first question is f a one-to-one function? Explain. Right, remember when we're doing one-to-one function, right? We first have to test if this passes the vertical line test, okay? Which this one, a straight line, does. And now we do the horizontal line test. Now, a straight line, which is a linear function, is a one-to-one function. When we look at this graph, all the way from this point going up to there, I do the vertical line test, it works. A vertical line test, it works. But the problem comes here when you've got a constant 2, which is your y equals to 2. So there's too many x's mapped to y equals to 2. So this is not a one-to-one function because it now fails the horizontal line test. So I can say here, not a one-to-one function, right? Because it fails the horizontal line test, right? So you've got, there's too many x's mapped to only one y, right? Now, so the next question, it says, sketch the graph of the inverse of f. Now, when we look at this graph, I've got 1, 2, and this point here will be 2, 2, and then up there it's 3, 2, and then there it's 4, 2. So my inverse, it's going to be the other way around. So I'm going to have 2, 1. So this is 2, 1. Okay. 2, 2. And, sorry. And then 2, 3. So I'm going to have a vertical line like that. For this part, from 1, 2 to 4, 2, then this is our graph. Now I'm coming to this one, okay? I had a 1, 2, so this is 2, 1. Now, with that, it is through not 1, so it means it's going to go through 1 not. And it does not touch, the original function does not touch the x-axis. So in this case, the inverse is not going to touch the y. So I have something like that. Let's see. It's going to look, it's going to go like that. Okay. So that is our inverse. Okay. So now we have sketched the graph of the inverse of f, and now it says maintaining the range, okay, give a restriction on the domain of f, the original one, that would ensure that what are we looking for here? The inverse will be a function. Now, if you look at your graph here, from this point, right, let's get a different color. From this point down, I don't have like the same y through for all those x values. So if I keep it from here up to when x is 1 and y is 2, then my inverse is going to be a 1-to-1 function. So you restrict your domain and say x should be less or equals to 1 so that your inverse will be a function. Okay, I hope that helps. Now, next question. Given the equation f of x equals to half x squared, is f a function? Explain. Okay? Now, we can draw a rough parabola sketch here. When x is naught, y is also naught. And if x is 1, y is a half. Okay, 1, and then a half, minus 1, also a half. And then if you've got a 2, negative 2, sub in, you get 4 divided by 2, so you have a 2, right? So now we get this as your parabola. Now, is this a function? You do your vertical line test. It passes the vertical line test. Therefore, yes, f of x equals to half x squared is a function. Yes, it's a function. Passes the vertical line test. Okay. Now, write down the domain and the range of f. Right. So now remember, we're looking at the x for the domain, and we're looking at y for the range. Now, if you look at your x values for this particular function, this is a continuous function, so I can have any x value from negative, right, through naught and to positive infinity, right? So you'll say your domain, x such that x is an element of from negative infinity to positive infinity, or you can just say x is an element of real numbers. Okay? Now, and your range, in this case, if you look at your graph, y can be anything except the negatives. So, but from 0 and up, so you say y is an element of okay, sorry. So from naught and up, including 0, so it's 0, including square bracket, right, to positive infinity. So that is your domain and your range. Now next, find the equation of the inverse of f in the form y equals to that. Now, remember guys, we're given y equals to half x squared. Now we all know how to find the inverse, where there is y you sub in x, where there is x you sub in y, and you make y the subject of the formula. So I get x equals to half y squared. All right? Now, the next thing, I need to make y the subject of the formula. I've got a half. Now, the undo of multiplying your half y squared is to divide by half, or just multiplying by 2 throughout. So you get your 2x is y squared. Now I need to make y the subject, so plus or minus the square root of 2x is y. Now, just before I hand in, I'm looking at this graph, y equals to plus or minus the square root of 2x. Now I have to restrict my domain here, because if I sub in anything negative, right, so anything less than naught, I get a square root of a negative number. So therefore I have to say then x should be greater, okay, we'll say 4x greater or equals to 0, then this will work. Okay. Now, write down the domain and range for the inverse of f. Right? Now, so we have our inverse. Okay, guys, we can just quickly sketch this graph. We have, now, and as we were saying here that x should be greater or equals to 0, so I'm starting from when x is naught. So I've got y equals to plus or minus the square root of 2x. Now, if I sub in naught, I get naught. So I've got naught, right? If I sub in maybe 2, all right, so I've got 1, 2. If I sub in 2 in this graph, I get 2 times 2, which is a 4 square root of 4 is 2, right? So it's going to be plus or minus 2. So I get 2 there, and then a minus 2 there. So this graph looks like that. Your x is greater or equals to 0. Now, let's talk about our domain and range. So I've got the x values, but can you see that I don't have negative x values, okay? So we're going to say domain is x such that x is an element of, I'm starting and including naught, but going all the way positive x's. So 0, 1, 2, 3, up to wherever, so to positive infinity, and then close, right? Now, and our range here, range will be y is an element of. Now you've got anything, this is continuous function, so anything from negative infinity to positive infinity. So y is an element of real numbers, or you've got your negative infinity to positive infinity. Do you have anything to?
Yes, I have some questions. The first one is for question 4.
Yeah.
This one comes from Paledi. Paledi is asking, what happens if the horizontal line is placed lower? Does it make it a 1-to-1?
If it's placed
lower, does it
one?
make it 1-to-1? Question 4.
Yeah.
What happens if the horizontal line is placed lower? Does it make it
Lower than what?
1-to-1? Lower than where it is.
Lower than where it is.
Yes.
So I think the student is saying, or the pupil or child, right? If it's lower than y equals to 2, right? If he says y is not equals to 2, I think that's what he means. So if the horizontal line test starts here, so you're excluding that part, so you will be having only this part, which when you do your horizontal line test, this will be a function if that is not part of your graph. I think that's what he means.
Okay.
Right. Now, yes, another question.
Another question from Dewo. When we have a square root in the inverse function, do we always have to put a plus or a minus?
Oh, very good question. Let's just get okay, right? Let me just do the, I've got that question. Let me just do the challenge question, and then I'm going to answer. I'll keep that in my mind, or the external hard drive of my head. Right, so it's given that g of x equals to 3x. Find a simplified expression for g of x, okay, the original part, plus the inverse, okay, this is the original one, okay, this is your inverse, and that's your reciprocal, 1 over g of x plus g of 1 over x. Now, let's quickly do that. Go to g of x, it's given, it's 3x. Plus, now, the inverse, you interchange x and y. So here you have your y equals to 3x. Then, to get the inverse, you've got your x is 3y. Then your y will be x divided by 3, right? So your inverse will be x divided by 3. Plus, now you have 1 divided by g of x. So this is given, I'm just going to substitute. So I've got 1 divided by 3x plus g of 1 over x. Now remember, guys, we have g of x is 3x. So therefore, g of 1 over was that x equals to 3 bracket in the place of x. I've got 1, is that 1 over x? So this is 3x. So that's 1 over x. Is that right? So that is going to be 3 over x. So in the place of x, I'm going to have 1 divided by x. So this is now 3 divided by x. Now, we need to simplify this expression. The denominator here is 1. I hope you remember from your grade 10, we're dealing with fractions. We look for your LCD. And in this case, I've got 1, 3, 3x, and x. And our lowest common denominator is 3x. And then 3x divided by 1, you get your 3x. Times the 3x, you get 9x squared. Plus the 3x divided by 3, you get x. X by x is x squared. Plus the 3x divided by 3x is 1. 1 times 1, you get a 1. Plus the 3x divided by x is 3 times 3. Was that 2 seconds? That's your 3 in the place of x is x, okay? Then you get 3 times 3, you get a 9. So in simple terms, you get 10x squared plus 10 divided by 3x. Anyone who's got something like this?
Let me look.
Okay, is a 10x squared plus
10x squared plus 1 divided by 3x.
Divided by 3x. Because we have got 3x into 3x, that's 1 times 1, you get a 1. X into 3x, that's 3 times 3. So I think your final answer should be 10x squared plus 10. No one got this
over
one?
3x.
Over 3x. That's 10x squared plus 10 all over 3x.
Yes.
Okay. Yeah. So that's the answer for your challenge question. Okay. Now, there was a question on. Can you repeat that question, Abraham, for me?
Yes, sure. They were asked, when we have a square root in the inverse function, do we always have to put a plus or minus?
Okay. Let us say we have y equals to x squared. And then you get your x, it's y squared. Now, it goes back to our grade 10 that when we were solving, say for instance, you get solve for x, you've got x squared equals to 4, right? Now watch, what is it that I can put in for x to get 4? Most people will be tempted to say it's 2, but you can have 2 or minus 2. So this part, you can have your minus 2 or 2, because if you've got minus 2 squared, that gives you 4, and the 2 squared, it gives you 4. So in other words, your x squared equals to 4, x will be plus or minus the square root of 4, which is plus or minus 2. Some of you are going to say, now watch, what's the other way of getting x from that? Is to say, okay, difference of 2 squares, so x squared minus 4 is naught, then x minus 2, x plus 2 is 0. So x is 2 or x is minus 2. Now, this case, the same thing. I wanted to make y the subject of the formula, okay? So I've got y squared minus x equals to naught. And then I can factorize this 2 equals to 0. So this is y minus and a plus, right? The square root of x, square root of x. Now, if you work this one out, you've got y minus root x, y plus root x. You get y squared and the middle term cancelled out. And then you've got minus root x times root x. You get just that x. So it's y squared minus x. So therefore, y is the square root of x, or y is minus the square root of x. Just a shorthand, y is plus or minus the square root of x. Now remember, if it's to exponent 2, you're making that the subject of a formula, so you'll have y equals to plus or minus whatever you have there. Okay.
Okay, here's another question. Delisile is asking concerning question 1b. Do the two graphs reflect around the line y is equal to x?
For
Question
was it
1.
the inverse of your graph. Now remember, it's not part of your caps, but when you're doing your inverse always is a reflection of your original function on the line y equals to x. Yes.
Okay. Another question from Tiamo. How should the domain of f is to x equal to 2? I think this one, it's a very long question. It's another
okay.
question. Let's take
No,
another one.
We'll answer it later.
How do you know the restrictions you have to use is in an exponential graph? How do you know the restrictions you have to use in an exponential graph?
Okay, let's just take one example on your exponential graph. I need to find. Oh yes, the learner. What's her name?
Karabo.
Oh, yes. Karabo, ne? Karabo is asking of the exponential graph. Now, remember, our next week's session, we're going to be working with exponential graphs and working the inverse of the exponential graph, which is going to be the answer that I'm going to give next week. So our exponential graphs is next week, and the other part, which is the inverse of the exponential graph, that I'm going to talk about next week, Monday.
All right. I think that's why we need to wrap it today. It's the end.
So too.
Thank you so much, Mindsetters, and keep on taking the test to solve questions. If you haven't got the right answers, try them out and then give us the right answers. The link is posted on Facebook, and you stand a chance of winning an awesome airtime voucher from Vodacom. It's worth 110 Rand to call all your friends and your loved ones. But if you missed the notes, they can be found on learn.mindset.co.za. Thank you so much, sir. It's been a great show, and the Mindsetters say they enjoyed the show.
Thank you. I enjoyed them too.
That's awesome, my sisters. Keep learning, because as I always say, that keep on believing in yourself, and if you stop believing in yourself, no one will ever believe in you. And all the best to all the matriculants that are writing their supplementary exams. We're behind you as Mindset, here to support you all the way. But for today, that's where we just have to wrap it. We love you, and peace from me, AB and Sihe.